Hi, scholars. We're going to just briefly talk about operating with fractions. In this case, we're going to talk about multiplying and dividing them. And we're going to do this rather quickly because we're going to look at this procedurally, right? So procedural ways of doing mathematics, these are sort of like the rules that we memorize, right? We can memorize these silly rules like flip and multiply, keep, change, flip, negative, negative, positive, whatever, right? These are sort of things that one can memorize, and they don't really have necessarily a whole lot of meaning to them. There's just rules, right? Now, we can contrast procedural ways of doing things with conceptual ways of doing things. And so conceptual ways are sort of like the big idea. These are sort of like ideas, and you can have images, like pictures in your head, right? About sort of the why. This is sort of the why behind math, right? So maybe some procedure works, and the question is, why does it work, right? So in the past couple of videos, and in general, right, you want about 90% of your math learning to be conceptual, because otherwise, well, there's no point in memorizing rules, right? At this point in our lives, you know, lots of memorization isn't really that important, right? It's more important to sort of make your own sense of the math. That being said, there are times when it is very useful to be able to procedurally manipulate, for example, expressions or algebraic expressions or equations. Do it without thinking, right? Say, okay, I know what to do in this case. So procedural knowledge, being able to push symbols around, right? Another way of thinking, we can consider this as pushing symbols around a page, right? There is a place for this. This is important, right? But conceptual knowledge is more important for sure, okay? And so, for example, conceptual knowledge is viewing 6 over 2 as a length of 6 measured with a ruler of 2. How many iterations of that length of 6? How many 2's fit into the 6? Oh, there's 3 of them. That's why 6 divided by 2 is 3, right? Procedurally, we could say 6x over 2x, and we say, I just know that I cancel the x's and the x's, and 6 divided by 2 is 3, and I'm done. Okay, for example. Okay, so let's take a look at a couple of examples procedurally. How do we multiply fractions? Okay, so we have two fractions. We want to multiply them. It's pretty straightforward. You multiply across, right? So I look at the numerators, 5 and 8. I rewrite this as 5 times 8 over, I look at the denominators, 2 times 3. And this, in fact, equals 40 over 6, which I can reduce to 20 over 3, right? Just by sort of dividing the top and the bottom, the numerator and denominator by 2, right? That's sort of what I'm doing here. Here, I'll just say this is what I'm doing in order to get to 20 over 3. Now I could have gotten there immediately by saying that 5 over 2, 8 over 3, and I just want to start comparing, does anything or any of the numerators, do they share anything with any of the denominators? And in fact, 2 and 8 share a common factor of 2. So immediately I could have said, let me cross out 2 and write 1. Let me cross out 8 and write 4, right? Oh, this is a terrible color, right? Let me write 4 here and a 1 here. And the reason why I'm doing that is because 8 over 2 is the same as 4 over 1, right? 8 over 2 is 4 over 1. Because 8, right, is 2 times 4 over 2, and I can cancel the 2's, right? And all I have left with is 4, which is just 4 over 1. And so if I'd done it that way, I could have done 5 times 4 is immediately 20, and 1 times 3 is immediately 3. I would have gotten the same answer. Okay, how do we multiply 5 times 8 thirds? Well, one way you can think about it is, if I have 5 of these 8 thirds, it's just 8 third plus 8 third plus 8 third 5 times, right? And we know how to add all of these fractions that have a common denominator of 3, we can just add the numerators. So that's 8 plus 8 plus 8 plus 8 plus 8, which is 40 thirds. Or I could just look and say, wait a minute, 5 times 8 is 40, right? So the quick way of doing it is you can just sort of multiply. 5 is a numerator, right? It's the number on the top. What's on the bottom? 5, 1, right? 5 over 1. We don't write the 1 often, but it's still there. So I can still multiply the top 40, multiply the bottom. The numerator doesn't change. So that's this answer, and that's this answer. And if we want to think about it a little bit, it does make sense because even though we can't really see it, this right here was 5 halves, right? And so 5 is 2 times 5 halves, right? And 40 is 2 times 20. Okay, that's fine. Let's take a look at one more. Dividing fractions. So how do we divide fractions? Procedurally. If I'm dividing two fractions, I keep the first fraction the same. So I'm just going to rewrite 3/5. I'm going to change division to multiplication, and I'm going to multiply that by the reciprocal of 7/10, which is 10 over 7, right? Okay, so reciprocal, the reciprocal of any fraction like a over b is, so we'll just write a sentence, the reciprocal of a over b is just b over a. I just flip them, okay? So instead of 7 over 10, I write 10 over 7, and then it's a multiplication problem. I can multiply across. So, okay, we end up with 30 over 35, otherwise known as 6 over 7. That's fine. That's our answer here. We're going to get into in a later video why this works, this flip, multiply, whatever algorithm works, but for now, we're just doing it. Great. So 3/5 divided by 7. Let's take a look at this. I can view it the same way. What's the reciprocal of 7, right? What is the reciprocal of 7? It's 1/7. Sure, because 7 is really 7 over 1, and I can flip it, right? 7 over 1 to flip it is 1/7. Really, the idea of the reciprocal is it's the number that when you multiply it, like if I multiplied these two things together, I'm always going to get to 1, right? So if in this case 7/10 times 10/7 is 1. In this case 7 times 1/7 is 1. When you multiply a number by its reciprocal, you always end up getting to 1. That's like the definition of it. So in either case, divide by 7 is the same thing as multiplying by 1/7, and that makes sense because you are taking a 1/7 of, I don't know, whatever, a cake. It's the same thing as taking that cake and dividing it by 7. We multiply across. 3 times 1 is 3. 5 times 7 is 35. And this is our answer here. Let's take a look at 7 divided by 3/5. Same principle. Let's start with 7. Let's find the reciprocal of 3/5, which is 5 over 3. And we're just going to multiply, right? And we can know how to multiply across. 7 times 5 is 35 over 3. And if we need to, we can say that 7 is really 7 over 1. So you multiply the top, the numerators, you multiply the bottom denominators. All right, so this is how all of these things work. And you might be interested, if you're interested, to consider the relationship between these two problems and the relationship between these two answers. Now that might be interesting.